I guess I haven't looked at this particular, okay. Alright, yeah, so this will be interesting. So we got 1, 2, 3, 4, 5. Yeah, so this tracing looks pretty choppy. But let's see what we can pull out of that. So to do the process would be the same, whether or not you're dealing with clean data or data, like I said, it's a little choppier. So to do the timing analysis, we want to do EMG threshold, right? So that's the calculation script that we're going to use. So it opens up this dialog window. So the catalog entry for EMG threshold calculation is, so a script will perform RMS calculation followed by baseline estimation, threshold rate operation, and return a square wave denoting activation periods as well as the RMS of the original input. So basically what this is telling us is, so we're going to be able to get the original root mean squared smooth data as well as essentially boxes. So it's instead of you seeing like an EMG trace, it's going to be a vertical line and it's going to box it in based on the start time and the end time of the activation window. All right, so that is where we get, that's the way to get the information of, okay, so it stops, and you'll see when we next look at Excel, you can see exactly where it stops, and then when another contraction comes in. Now, that's probably like the distance or the time between contractions is probably not like experimentally relevant for this collection. Dealing with the bicep curls, we didn't, that's not really like locomotion or anything like that. It might be a little bit more, informative if we're going to look at the 5-meter walk, which we will. But just kind of getting the basics down. So you see this dialog window. We have a lot of the same information as in the previous analysis that we did on Tuesday. So you see we're getting a lot of information. We're putting in a lot of information about the root mean squared, right? So that pretty much stays the same as you would normally want it for the standalone RMS. And then the two things that are actually relevant for us to kind of pay attention to are the baseline level and the window length. All right, so this essentially is telling you how sensitive the calculation is going to be for determining whether a muscle is on or off. Right, so most of the time, I usually just stick with the recommended baseline level window length, so 5 and 0.4. But based on what we see, and I think we're probably going to have to do that in this one, we probably have to adjust that slightly to kind of fit the data we're dealing with. So we'll take a look at what that entails in just a minute. All right, so Alright, so I'm going to run this script. Alright, so this is our RMS tracing up top, and down on the bottom portion of this graph, that's where kind of the square diagram is going to be. Now, obviously, this doesn't really make a lot of sense to look at, so we need to do one more analysis or one more calculation. And basically what we need to do is we need to scale that window and re-offset it so that we can visualize the whole graph at the same time. So we need to do another calculation script, and we go to scale and offset. And what we're going to do, so we need to actually adjust this this window here. So we need the scale factor and scale type. So the scale type is going to be fixed, right? So we're trying to essentially just create a window that's large enough for us to view what we're trying to do, which is those boxes. So I kind of look at the y-axis of our RMS tracing, and I kind of just look for roundabout where we're going to have the highest activation. So 0.001 volts. So I'd probably say 0.0012, right? So I'm going to say that. It doesn't really matter in terms of the data, it just matters in terms of the visualization. Right, so let's do that. All right, so yeah, there we go. So now we have at least an estimation of on and off timing based on the standardized settings of the original calculation, right? So one thing you want to do is plot overlay of the scaled EMG threshold data and the original root mean square data. So we can plot that overlay. And you can actually take a look at where each of those on-off calculations are coming from, right? So a couple different things that I look for. So one is, are we getting kind of some random spikes? Are we getting random boxes in here that aren't actually maybe contractions that we're interested in? And two, I want to look at the vertical lines that are represented in green here. I'm going to actually change the color names. Let's just go with that. So the vertical lines, so I'm trying to determine if it makes sense, right? So sometimes, especially based on that window length setting in the EMG threshold, right? Sometimes you end up getting a little bit too short of window, so you'll get the vertical line is cutting off the activation a little bit early, or it's taking too long to detect that it's actually on. So you might want to adjust that. So it's not really an exact science of determining those settings. So a lot of times, up to now at least, I've had to kind of just tweak it, kind of play with it a little bit to kind of get the activations that we're looking for. I don't know if we're actually going to be, with this particular data set, I don't know if we're going to be able to eliminate some of this noise, because it looks like the amplitudes on some of those spikes is a little bit kind of larger. So we'll see what we can do. So I'm going to go back in to run calculation script, so EMG threshold. I don't think changing the baseline here is going to affect much, but let's just see what happens if I increase it to 10. Let's see what we get, right? So you can kind of visualize what that does to the data set. Right? So I'm just gonna do real quick scale. Let's go. Okay, so it looks like increasing the data, increasing the baseline doesn't really do much for this. Let's see. So it eliminates a little bit, it eliminates the initial spike. It looks like that's the only thing that it actually does there. So that increased the threshold that is needed to detect that the muscle is on, basically, right? And that initial spike here wasn't really enough if we increase the threshold of the baseline threshold. So let's go back in again. I'm gonna real quick, I'm just going to go in and say, okay, what happens if we move that baseline level down to 2? All right. Right, so that is going to affect our result here, it looks like. maybe some of those are now coupled together, right? Which is probably what is happening like we talked about. There's probably multiple peaks that were associated with a single repetition here. We don't really know because, like I said, we don't have the goniometer or the motion capture integrated in there to determine, like, okay, well, what was happening with the joint at that moment. So we're just kind of, feeling our way through the dark with this, so to speak. Hey.
So does it mean it recorded 3 curves?
Say it one more time.
So there are 3 blocks, right? Green.
Right.
Does it mean 3 curves?
3, no, yeah, so that, I don't know exactly, because like I said, this is kind of like a choppy data set, but this could be one curl, right? And we could be visualizing, like, we could see, the increase here, like the concentric phase, and then, like I said, whoever this was might have like held at the top and maybe like isometrically contracted and then like paused and then went down. That's possible. It's kind of hard to say without any additional data. So, but yeah. So I'm not sure exactly on this case. We'll see if we can find. We'll see what the. Let's see what the. Yeah. So this is our 5-meter walk. I think this is going to be a little bit more kind of interesting to look at, and this will be a little bit of a better indication of kind of how we can tailor some of the settings to actually get activation windows, because we have these little minor spikes here, which are likely nothing, right? Or maybe some crosstalk, so that could be due to the electrode placement, so we might be picking up on maybe a muscle that is more responsible for dorsiflexion there, right? So I'm not entirely sure, but that seems like that we have some crosstalk or noise associated there. Right?
Were we using the second sub data? Unlike last time, we were always using the first sub data.
Well, I was just graphing this. You're talking about using the raw data.
The first one is the raw data, right?
Yeah. Correct, yeah. I was just graphing to see if this was a little bit cleaner of a setup.
Okay.
To do the threshold analysis. So let's just go through normal, like I said. I think we're going to make some adjustments to this one too. Let's see. I'm going to say, oh wow. Okay. Yeah, let's just go to that top. Okay. Yeah. So notice that we're getting a lot more maybe than we expected, than we want here. Right, let's plot overlaid again. Right, so we're getting some of these random spikes that are showing up in our trace here. All right, so let's see if we can actually get some good data out of this. So let's think maybe if we go down to like baseline level 3, I think the window length is probably fine. All right, there we go. Going to increase that scale factor just a little bit, so just a little cleaner. So yeah, maybe that's looking a little bit better, but we're still getting some of those extra spikes. Let's see. Let's see if we increase our baseline level. This looks like it might be a little bit cleaner. I'm gonna do one more, gonna increase a little bit more. So I did 7, let's move up to 9. So this looks a little bit cleaner. Let's take a look at our overlay data. One thing I don't know how to actually move this. I think I can probably do it in properties somewhere.
Do you want legend location? Is that what you're looking for?
Yeah.
Yeah, at the bottom of this one.
Oh, sure. Oh, perfect. Sweet, thanks. Never mind. Good for nothing.
We all knew that.
Yeah, that looks a little bit better. So we've eliminated some of the spikes by increasing the threshold. We're still getting this here, and I think that changing the window length, increasing the window length a little bit would create that as a single contraction. But yeah, and then also we have some of those, some of that, what I was talking about, where the vertical line is kind of cutting off some of that contraction time. So again, we need to go and probably play a little more. I'm not going to sit here and do it 100 times. The idea is you're trying to make your data based on your qualitative observation of it. You want to make sure that it looks decent before exporting to Excel. So we'll talk a little bit more as we get into the Excel next week about how we actually will calculate this. It's a little bit easier to conceptualize with like when you have multiple muscles that you're collecting that are all involved in like a single movement. So we'll do that next week a little bit. I have some data. I just decided not to do that for class today because I wanted to kind of just go through like the basic rundown of how to do the timing analysis, not so much as doing the actual analysis we would do in Excel.
So then, the files you want turning in by this number, you want Excel files, or do you want the EMG files?
So you will export them to Excel, yeah. So on this portion, make sure that you are exporting not only the threshold calculations with the boxes, but also that you're exporting the RMS tracing as well. So we have both of those. If we go back into the data later, we could, without having to go to EMG Works, we could visually inspect that, looks good and that it makes sense for that, on-off type analysis.
Should be overlaid together like that, right? The threshold and the root mean square overlaid like that in one graph, right?
Yeah, so I think to do the export, I think you need to highlight
Both of them?
export to Excel. We'll see. So this just gave us the, you might have to export them separately. I think that's what you have to do.
Greatly.
You have to export them separately, and then you can combine.
Copy and paste.
Yeah, exactly.
Because the time column is the same. I
Yeah,
guess,
the top
yeah.
column should be the same, yeah. So, and you also notice if you go into the threshold analysis without doing the scale, since everything is set at standardized 1 for that scale and offset, that everything will be shown here as the same number versus, well, it would be the same number here as well, but it would be whatever you set your fixed scale would be. So that's how you know where exactly the contraction starts and stops, because it goes immediately from that vertical line to 0, basically.
So the scale means so 0.00012 means that when the muscle was activated and the number 0 being deactivated.
Correct. Yeah. Correct. So it's just a binary yes or no.
Either A or B.
Yeah.
So the block means that when it's at bottom it's deactivated and when it's at top it's activated, right?
Yeah. So the vertical line represents like 0 time passing. So it just basically that contraction window just fits within here, and then whenever it goes back down, that means it's not contracted yet. All right, so let's, does anybody have any other questions before we get here?
And so the Excel files, do you want the RMS data for EMGs and also the timing as well? So working square, and also do you want just the raw files as well, really on top of that, or do you want to
Just the analysis file is fine. It would be good practice though to have so basically what I'm asking you to do is add to your Excel file that you created on Tuesday with the amplitude analysis, and just add additional tabs to it so that in this instance we have one Excel file that contains all the data that we need for that particular participant, so that we can calculate what we need, and then pull it into a centralized data analysis file. We can run group analyses or basic t-test, correlation, whatever type of statistics are necessary for that. So
What if I submitted the
that's fine.
Yeah,
So
last
I was
night.